did I answer your question or something you wanted to know, right? Srishti. Vihan, did you have a question still? Do you have a question still?
I'm doing it almost done.
Take your time and tell me and go. That's fine. Okay. So now for the geometry. Give me 1 minute, guys. We were on methods. Okay. Now I really wanted to know, Ashita, what are you doing in school?
We have a test over surface area, volume, and cross sections tomorrow, and we started triangles. We learned the exterior angle theorem.
It's nice. Okay. No, that is something I want to cover, but I want to cover it in my way with respect to the 2D, 3D, right?
Mr. Priya.
3D, what have they covered, ma? Volume is what they've covered?
Yeah,
What
they covered lateral surface area, and volume for 3D
for 3D,
objects.
na, did they cover till spheres?
Yes, like we didn't go really deep. We just learned how to figure out the surface area and volume of them.
Work. Okay. How about Kayura? What are you doing in school?
I'm still in Algebra 1.
I'm forgetting. Sorry. Okay. No. Then that's not a question for you at all. Sahana, Srishti, can you educate me? Mitransh as well.
So we're doing like 2-column proofs.
You're doing 2-column proofs. Oh, okay. Yes, ma. Yes, you have time, Ashrita, as well during the break.
Okay.
Okay, you have time as well. Wait. Okay, hold on. Okay, wait, let me see. So I want to go to 3D. Hold on.
Miss Priya,
Yeah, ma.
I asked in the Google Classroom what 3B is because I didn't know. That's why I didn't do the homework because I wasn't sure what that was.
Did I make a mistake of saying the wrong thing? Let me check. I thought I didn't. I don't know.
Because it said do these pages in 3B, but I didn't know what 3B was.
You're in the wrong classroom, lady.
I am?
Yes, 100% you are. Wait, let's see what is the problem.
I'm in.
I have to fix it. I have to fix it. For sure, you're in the wrong room.
I just joined the classroom that was in the email.
Interesting. I will look at the problem later, but for now, can I give you the right classroom?
Yeah.
Definitely, you're in the wrong classroom. That I know. Maybe it's my problem. Sorry if that's so, or your problem, whatever it is. Please copy the first correct classroom now. I will deal with it later. Okay.
Okay, thank you.
But first, join the Google Classroom. It should say geometry.
Yeah, I will.
Okay. Now I'm going to go into 3D. 3D. Okay, guys. 3D. How are you doing, Ashit? Are you memorizing formulas?
I have all of the formulas memorized.
What is it, ma?
I have all of the volume formulas memorized. And for like surface area, I know some of them, but the rest of them I just figure out by just using the faces.
Okay. Okay. Don't
We
memorize
also
something. Uh-huh.
and we also have the reference sheet for the tests, like the geometry star sheets.
Yeah, ma, but don't refer to all that, ma.
Yeah.
Okay, now let me quickly go over this 3D number of faces and stuff. Let's see. How about this? Let's get to this 3D. Any questions in the homework on the quadrilaterals, guys?
This will come up with really easy.
Very easy. Oh, the part squares, rectangles, rhombus, right?
Yeah.
If you start remembering the properties, not a hard one. Okay, now here, do you all know how to find edges, vertices? Do you all know how to find the edges, number of edges, vertices, and let me write down edges, vertices, and phases. How many are they, guys? Here,
There are 8 edges.
8 edges. How do you find out the edges? Edges are the lines, right? 1, 2, 3, 4, and 4 up. 1, 2, 3. Okay, good. 8 edges. Vertices are what?
5
1, 2, 3, 4, 5. Phases
and
are
5 faces.
yeah, see, how do you do the phases? For the phases, right, always check front, corresponding side is back, then right, corresponding side is left, then top, bottom. Here it's a pyramid, right? So what happens? One, base, bottom is there, top will not be there, then right, left is there, front, back is there, correct? Right, left is there, front, back is there, because it's a square, right? So there are how many faces? 5 faces. Any questions, guys? I really want you to understand this Euler's formula too. Have you come across the Euler's formula for this?
No.
Okay, I really want you to at least know that. I know it's not a part of your school math, but it's a good one to learn. This guy was a famous mathematician. He worked on 3D solids, okay? He worked on convex polyhedrons. For any convex polyhedrons, you can say V minus E plus F is always equal to 2. There's a famous book on it, a small kid's book, actually, elementary school book on it, okay? This Euler mathematics worked on 3D solids and found out the number of vertices minus the number of edges plus the number of faces is always equal to 2. Is always equal to 2. I just gave you the formula directly. Okay, but immediately the question would be, hey, what is a the convex polyhedron, right? I really want you to want to give you some examples. Let's see. Okay. These are all convex polyhedrons. I'll show you. Let me see. These are all convex polyhedrons. I'm going to erase this off. This Euler's formula is very famous, okay? Just get to know. It's always equal to 2. V minus E plus F is always equal to 2. So here, these are all convex polyhedrons. A line segment that, see, what is a convex? Convex means in all these shapes, when you think about it, a line connecting any 2 points will always be contained within the polygon. That is convex. A line containing any 2 points will always be contained within the shape. That is why we refer these figures to as convex. All interior angles are less than 180 degrees. Okay, so those are convex polyhedron. In any convex polyhedron, number of vertices minus edges plus faces will always be equal to the number 2. Can I move on? That's a check you can make. Okay, this is very popularly used outside, not in your school math though. But you should know this. This guy was Euler. He was very famous to have done this thing. Can I move on now? Okay, now you know how to find out faces, edges and all. I wanted to go over something else. Okay, how about this? What is a hendecagon? What is a hendecagon? What is a hendecagon? What is a dodecagon? I'm still in 2D. What is a hendecagon? This is a 11-sided polygon.
And dodecagon is the 10-sided polygon.
12-sided. Do is a 2, decagon is a 10. Dodecagon is a 12-sided polygon. Mm, yeah. Have you heard of platonic solids? Huh?
No.
Okay. There are 5 platonic solids in mathematics. Let me go ahead and give you that as well. These are extra information which you guys, it's nice to know, guys. Okay. In mathematics, there are only 5 platonic solids, meaning Plato, the mathematician Plato described 5 solids. Okay. These are the ones. Basically, when you think about it, each of their face is a polygon, is a regular polygon. Tetrahedron has triangles, 4 triangles. When you think about them, these 4 are equilateral triangles. Similarly, for a cube, right? Let's say for a cube. Cube is basically a hexahedron, meaning a 3D shape with 6 faces, right? It's a hexahedron. So in a cube, see, each of the face is a square. Each of the face is the same as the other, right? Similarly, octahedron has again triangles, but 8 triangles make up the octahedron. 8 faces are there, and all the 8 faces are equilateral triangles. Similarly, you have see, I just told you about dodecagon, right? This is dodecahedron, 3D figure. I told you about dodecagon. It's a 2D figure. Dodecagon is a 12-sided polygon, I told you. But this is dodecahedron, where each of the face is a regular pentagon. Similarly, the last one is icosahedron, which has 20 equilateral triangles. These 5 are very famous. Okay, they are unique. Why? Because each of the face is similar to the other face, meaning all the other faces that they have. And each is a regular polygon. Can I move on? You should know when somebody talks about platonic solids, yes, I have discussed this in class, you should be able to say. Can I move on now? Okay, there are only 5 platonic solids though. Okay, now rotation and all we discussed earlier, if I could remember right. So cross sections I'm not going to do today, but directly jump into surface area of prisms. Okay. Let's say, let me start with a small one. Okay. Let me start with a prism. What I'm drawing. Okay, let me start with a triangular prism. Okay, now this is a triangular prism. The corresponding pyramid is, it's a triangular pyramid. I'm going to draw this like this. Okay, now guys, for this triangular prism, right, what are the bases? See, this is the parallel cross section. When I am able to touch it on the sides, it is a parallel cross section. Whichever has a parallel cross section ends with a prism. Whichever has a pokey point is a pyramid. This is a triangular pyramid. Right, I'm starting with the minimum polygon. The minimum polygon that I know is a triangle. So I'm starting with triangle. These triangles form the bases, correct? Triangle is the minimum polygon that I can think of. So triangular prism, triangular pyramid. Okay, now when it comes here, right, let's discuss the surface areas. 2 things we need to discuss. One is the surface area, one is the volume of all of these 3D solids. Now coming to the first one, right, how do you find the surface area? Surface area is just the area of all the faces. So how will you find the surface area of this triangular prism? Come up with your thoughts, guys. I don't want you to memorize any formula. Okay, I really don't want you to memorize any formula anywhere. But there are a couple of places where you might want to memorize, but these are not something to be memorized. So how to find the area of each of the face? How many phases are there in this? How many phases are there in this? Srishti, you want to say, or Mitransh, you want to say?
5.
Good, 5. So top, bottom. As I said, right, faces itself, always remember top, bottom, left, right, up, down. Top, bottom is there, right? And then how many side faces? Meaning side, how many sides are there? In the top, bottom we covered.
3.
Yep, 3 sides because of the triangle, right? So 3 sides, let me say. So this is the faces. Now we have to find, for the surface area, you have to find the area of each of the faces. So basically the top and bottom are triangle. This is a triangle, this is a triangle. Right. Now 3 sides are there, right? All the 3 sides are rectangles. You know how to find the area of the rectangle clearly. You know how to find the area of triangle. So area of the triangle, area of the triangle, area of 3 rectangles will become the total surface area of the triangular prism. Now let's go to a pyramid. What will change? What will change in the triangular pyramid? How will the surface area change? All the sides are triangles, right? So area of four triangles will be the surface area of the rectangle. Any questions? That will be the surface area of the rectangle. Now let's work out 1 or 2 problems, then only, otherwise you will not remember anything. How about this? Okay. Remember, when you find the area of the triangle, we all have studied area of the triangle is base times height, right? This base and height should be perpendicular to each other. The base and height should be perpendicular to each other. If they are not, then you cannot consider them as base and height. Whenever you find the area of a triangle, the base and height should be perpendicular to each other. Before you go with this problem, right? Let's say there is a triangle here like this. Let's say there's a triangle here like this, A, B, C. What is the height of this triangle? The height can even be outside. Nobody will bother. But the height should be perpendicular. If I consider this as my base, this is my height. Height can be outside, does not matter, but it has to come from the opposite vertex from the base to the base. So here it's perpendicular. Suppose if I consider this as my base, right? How will I draw my height?
It
From
would
the
come from
opposite vertex, I drop down a perpendicular. This is my height. Any questions, guys? If this is my base, anything can be the base, anything can be the height. But the height and base, whatever you choose, should be perpendicular. Now, you know how to find the surface area of this triangular prism. Top, bottom areas, they are triangles, and then the rest of it all are rectangles. So just find out the total surface area of this prism. If you want quickly, you can use calculators for computations.
Miss Priya. Is this the 2 representing the height of the whole figure?
2 represents the line that connects the bases.
Okay.
So when you find the area of each of the face, think about each face. Think about each face. Get the help guys immediately if you don't get it. Kayura, I
Miss
don't know
Priya,
what
can you check my
happened.
answer?
Yeah, I am going to. Give me 1 minute. Kayura, I don't know how an incorrect email went to you. I'm going to check on that as well.
I went to the link that you sent just now at the beginning of class, and it said that classroom isn't like a real classroom. It said no classroom found.
Amma, use the code, Amma. I gave you a code. There's a code at the end, right? You can use that. Join
Yeah,
with
okay.
code.
Okay, one sec.
Uh-huh.
Okay, I joined the new class.
Okay. I got so many answers. That's nice. Where is it? Yes. You know, okay. Shraddha, correct. Have the units in place as well. Mitra, and somewhere something is missing. Okay, total surface area. Some of you finding it incorrectly. Sahana, did you get it? Mahir, I really would like to see your answer too. Uh, Sahana, can you tell me what are the numbers you used? So, see, top and bottom are exactly the same, I would say. This, oh my, what I'm doing. This is the same as this, right? So, top and bottom are the same, but I have to multiply by 2. Top is a triangle. So, half times 2.4 is the base, and this connecting perpendicular is the height. So, bottom also follows the same thing, right?
So it would
Half
just be 2.4.
Yep. Now, after that, for the faces, right? For the side faces, right? Side faces, right? This is 2.4. We know 2.4 times 2 is one rectangle. Front. Front is 2.4 times 2. But then, when you look at the side, right, it's a little tricky. This is 1.5 times 2. 1.5 times 2. Similarly, the same 1.5 gets copied over here, I would think, right?
No, that's 1.7
No,
because
this
of
is
what's given.
1.7. Yeah, 1.7, Emma. So this is 1.7. See here, this they've given it as 1.7 times, what is this? 2.
2.
1.7 times 2. Each phase is different. You see, that is what is making it hard. Right, left. So think about each phase. Now it's just computation. Sahana, where did you go wrong, ma?
Is mine's
1.2.
correct, Miss Priya?
Huh?
Is mine's correct?
4.8. I'll check my right away. 3. And then 1.7 times 2 is 3.4. When I add all of this, 2.4, 4.8, 6.4. 4 plus 8, 8 is 16, 1. I'm getting this. Meter square. Unit is important, guys.
That's what I got.
Yeah, that's good. Sahana, did you get it? Srishti, where did you go wrong, ma'am? See, the problem is ironing out each figure's length and width. Yes. Mitransh, meter square.
Yeah.
Keura, somewhere something has gone wrong. Did you see, ma?
I forgot to do the front face.
Yeah, I think I wrote the things wrong as well, like the
Yeah, the numbers, right? Yeah. It's very easy to go wrong there, meaning it's nothing related to your conceptual understanding, but just that you need to see the figure correctly. If you are doubtful, right, just shade it and see, are you doing it correctly? So this back, the left face, the left side is 1.7 times whatever is standing up, 2. Make sense? The right hand side is 1.5 times 2. The front face, which is the front face? Front face is this one, right? This one. Front face is this 2.4 times whatever is standing. Bottom and top are similar, but that's a triangle, and considering the base is this. Considering the base is this, this is your height. So this is 1 meter times 2.4. Make sense? So you need to be very, very, very focused on the diagram. Now, there's something called total surface area. You all know. we found the area of all the faces and found out total surface area is 13.6 meters square. But this is the total surface area. I write it out as TSA. There's something called lateral surface area. What is lateral surface area?
Surface area excluding the bases.
Yeah, exclude the top and bottom. Exclude the top and bottom of 2.4. Okay, lateral means side. So they're asking lateral surface area means side surface area. So from this, you can exclude 2.4. That is your lateral surface area. Any questions? Okay, now let's see this one. So given anything, you should be able to find out nicely. Now, okay. Let me see. Hold on. Okay. Let's see. Just 1 second, guys. Okay. Sometimes these 3D solids, right? When they stand up straight, we call them right. Meaning, see, this is one way, this is another way. You're going to do this again. See, okay, let me not erase that. Okay, let me draw it by the side. When you think about these two solids, right? What is the solid called? What is the solid called? Both are, I know, triangular prisms. But there's a difference between the two. What is the difference?
The one on the bottom is slanted.
One on the bottom is slanted, but what is it called? This is a right triangular prism.
Why is it called that?
Because it is standing straight. When you think about it, the bottom and the standing edge, right, they are at 90-degree angle.
Okay.
That's why it's called a right triangular prism. Whereas when you look at this, right, you see, meaning this itself is tilted. Am I making sense? This itself is tilted. So you don't have the height here at all. The slanted height, you cannot take it. Meaning for the rectangles area, you can take that. That's great. But this is 5, we know. That's okay. They have given this as 12. So this is 12, we know. So when you look at it, the triangles area, the rectangle areas, you can find out very quickly. But when you think about the height of this triangular prism, this height is different. Now let's see this one. I want to show you something here. This is called oblique triangular prism. Any questions here? Any questions here?
No.
Okay, if this was this was the height. If it was a right triangular prism, this was the height. But in the oblique, right, see, this and this are at right angles. You see? But when you think about this face, right, this. This phase, right, it's very difficult to find the area. What is this actually? This is a, what is this phase? What is that face, guys? What is the shape of that
It's a
face? The
parallelogram.
parallelogram, yes. Makes sense. So how do you find the height of that face? How do you find the height of that face?
You have the base and the
Yeah,
slant
you have the
lines, so
base,
you can do
correct? But the
Pythagorean theorem.
this is the base, right? Because they have given the base.
Yeah.
How do you find the height?
Can't we use the base and this measure and use Pythagorean theorem to figure it out?
Um, Base is there, ma, but you can't, right? Meaning Pythagorean theorem you can't use, right? Because you know only the hypotenuse, right?
Right, no.
Um, I have a quick question. You have not been introduced to trig yet, right? Trigonometry, right? You have not been used. Have you
Not
been?
in school, but I know what it is.
Okay. Okay. I really want you guys to know. Okay. I know trigonometry. I'll go there a little later. I should have taught that first, I feel. But wait, let's see. That's okay. But I can introduce you to get used to that now. If you see a right triangle, right? If you see a right triangle, there are some ratios. Mathematicians have come up with some ratios. Okay. See, for that matter, this mathematician Hipparchus was the first person who developed this area called trigonometry. He was the father of trigonometry. Okay, this mathematician did a lot of work, and then Indians took it up, and it became very famous. Trigonometry, meaning these are the ratios that we define in trigonometry. Measurement is metry, right? So we measure right triangles and we understand all pieces of the right triangle using this trigonometry. We define some ratios as well. In any right triangle, if you consider this as an angle theta, they have come up with 6 ratios. Okay, sine of the angle, these are the ratios that they have already defined. Cos of the angle, tan of the angle. That is enough for now. When we go to trigonometry, I'll explain that all in detail. You should know 3 ratios. Okay, 3 ratios. What are these 3 ratios? Sine of the angle is defined as, for this angle, right? This is the angle I am considering. What is the side opposite to this divided by your hypotenuse? So I call it as opposite side by hypotenuse. Similarly, there is one more ratio that has been defined. Considering this as your angle, this side is sitting adjacent to the angle. Adjacent means sitting next to, right? It's touching each other. Do you see? So this is the adjacent side. So cos of the angle is adjacent by hypotenuse. Okay, make a note of it. This is quite important. This is the opposite side. Now, just the 2 is enough for now, for that matter. Okay, the thing is, suppose the same right triangle. Okay, let's consider this is the angle theta. Right triangle, you should know everything about it when you study trigonometry. So, if I take this as the angle, right? Now, sine of the angle is given by what? Sine of the angle is a ratio that we define. So, what is it? Opposite by hypotenuse. So, what side by what side? Can one of you tell me? Always, if it's the opposite side, it's the side opposite to that angle. If it is the adjacent side, it is the side that is sitting by the side of the angle. So, in this case, can you tell me, considering this as the right triangle, this as the angle theta, what is sine theta? Sine theta is always defined as
Opposite over
opposite by
hypotenuse.
hypotenuse. Can you help me from here? Opposite by hypotenuse means what is the opposite side to theta?
The opposite side is BC.
BC. So BC by
AB.
BC by
Never mind, AC. AC.
AC, hypotenuse, right? Yeah.
Yeah.
So the advantage of this, what is the advantage of this? Why are we doing this now, right? The thing is, mathematicians have established these ratios already. Meaning, if I give you the angle as 60, I know what is sine of 60. I know what are these, what are the values of these. So even if you're not given one of the sides, right, you'll be able to find it with ease. Meaning they've established the sign of these angles already. So if you put into the calculator sine of 60, you're going to get what is the value of it easily. So when you get that value, you don't need to know all of the sides. Even if one of the sides of the right triangle is given, you can find the other sides. That's the best application of this. So suppose if, see, in this right triangle, when you look at it, right, they've given only one side. Which side they've given? This side is 18. Hypotenuse they've given. But the angle they've given, you see, with this, we know what is sine 72. If you put it to the calculator, calculator will tell you. So sine of 72 you know, but you need to find out the height. What is that ratio? Sine or cos connects this opposite by hypotenuse. What connects opposite with hypotenuse?
Sine.
Sine. So you will put sine 72 will be equal to h by 18. See, now easily you are finding h will be equal to 18 sine 72. Sine 72 is a value you can put in the calculator. 8 times that will give you the height. Does that make sense? This is why we use trigonometry. So we don't need to delve deep into trigonometry right now. But then when you think about a right triangle, based on wherever your angle is, sine of the angle is defined as opposite by hypotenuse. Cos of the angle is defined as adjacent by hypotenuse. How to remember this? Tan of the angle is opposite by adjacent. I'll tell you how to remember this very easily. You don't have to sit and memorize here. SOH. So, CAH. Cat. T. So, keto. TOA. You see? SOH. CAH. So, kata. So, here sine is opposite by hypotenuse. Cos is adjacent by hypotenuse. Tan is opposite by adjacent. Any questions? This is a very famous meaning. This is the acronym you can remember. Make sense? So we just went over what is sine of a sine of an angle in a right triangle. What is cos of an angle in a right triangle? Tan of the angle in a right triangle. Why are we using that? We don't need to know all the sides. We can compute provided one of the angles is given and one side is given. So that's the application. So this can be used anywhere wherever we see right triangles. So this is one area where you can apply that and find out the height. Does that make sense? Yeah,
Yes.
I didn't mean to confront this now, but anyway, it's not a hard one. So I just gave you the insight into how to find those. Here,
Yes, Priya, a clarification. So regular sine is when we're trying to figure out a side, but sine inverse when we're trying to figure out an angle.
uh-huh, is
Okay.
that coming here?
No, not here. I just wanted to ask
Yeah,
in
yeah,
general.
we'll go over that. So, okay, you want to find the theta, you're saying? You want to find the angle, right?
No, like I was just asking
Suppose they give
generally,
you
like,
this is 5 by 7. Now you have to find the angle, right?
uh-huh.
So what do you do here? See, just like multiplication is the opposite of division, division is the opposite of multiplication, addition is the opposite of subtraction, subtraction is the opposite of division, right? Here sine theta is equal to 5 by 7. So I'll have to go for the opposite operation because I don't know theta here, right? So you know what I do? I take inverse on both sides. When I take inverse on both sides, it gets you this, correct?
Yeah.
Now, sine inverse and sine are opposite functions. They cancel out. So see, this is not for all. You can leave it. We'll go there later, okay? Sine inverse of 5 by 7. So in the calculator, this is present as arc sine. Arc sine is another function. You can press arc sine of 5 by 7. Will give you theta. Make sense?
Yes, that
Ashok?
makes sense.
Okay, so that we'll cover later. For now, when you think about it, how to find out the height? Who's going to tell me how to find out the height? How to find out the height here? We don't know the height, right? That height we need to know for the parallelogram. So how to find
18.
in what ma?
Like sine cos equal to
You want cos. Why you want cos? This is
10
opposite by
times.
hypotenuse, right? So sine 72 is h by 18, right? So what is h? Mitranj, go ahead. Why did you close your mouth?
That's where I don't know.
Don't worry about it. Multiply by 18 on both sides.
Oh,
Multiply by 18 on both sides. What happens? H is what?
18.
18 sine 72. How do you find this? It's not hard. Let me show you. I'm going to share screen with you because I want you to remember certain things when we move to trigonometry. So I'm going to share screen. This is quite important, guys. Okay, I'm going to go to TI-84 Calc. I'm assuming all of you have that calculator with you by now. Everybody should be. My TI-84 Calc. The website itself is not working. Why? That's not good. One second, guys. TI-84 Calc. Okay, that's better. Okay, for now I have something going. See, now when you have a look at this, right, there is something called the mode. Whenever you use trigonometry, the first thing you're going to do is go to mode. Make sure the angle is in degrees if you're working in degrees. Where is the angle? I don't know where is the angle. Let's see. See, it's wrong. See here, radian or degree. You should point to degrees, enter. It's a very common mistake. If you forget it, all your problems will go in wrong. You don't want to be in a position where you get everything wrong because of this. Your mode should be in degrees if you're working in degrees. Now I'll go back, clear? I'll go back here. Sine of 72 is what I want, right? Sine, directly there's a function, sine 72. That's it, bracket close. Copy this, 0.951, that's all, right? So let me go back. 0.951 means I'll go back. That's all. That's the only one thing I wanted. 0.951, right? So H was what? H was 18 sine 72, right? This was 0.951 times 18. That's the height. So for the parallelogram, height times the base is the area. Now, can I leave it to you all to find out the total surface area of this oblique prism? Maybe your school will cover this later, but it's okay to learn it now. Total surface area of the oblique prism would be the top triangle area, bottom triangle area. Slowly you have to go, but you have to do it correctly. I'll wait, guys. Bottom triangle area, front parallelogram area, and then the left rectangle area. What is the right? Right is what, guys? Right, what it is? A rectangle or a parallelogram?
Parallelogram.
rectangle.
I'm not thinking of it as a rectangle.
It's a parallelogram because like I was thinking because the left right the left one they like marked all of the angles as right
Exactly,
angles.
correct. They marked it off. So left is clearly a rectangle, but right is a parallelogram. So these are cases which are a little difficult in geometry. So I will leave it to you to find each of these. Let me know
The
if you
height the height do we just do 0.951 times
yeah,
18?
yeah. Height I helped you, right? Height will be equal to, what was that? 18 sine 72. What was that, ma? 0.951, right?
Yeah.
times 18. Now you can do it. Let me know. I can also work, if you want me to work on it, give me the answer as soon as possible. Otherwise, I'll work. Can I help? Maybe I'll also do is my thought instead of. Let me see. That's a hard one actually. But we can do, guys. I want to do too. Let's see.
Yes, Priya, I sent my answer.
Got it? Okay. If you guys get it, I won't do. Mitransh. Aha, no ma. That's a hard one actually. Let's see. This is 90. So this 90. Right side is a parallelogram. Feel it's a parallelogram. Let's see. Top triangle area is. I'm also going to do because I didn't get any correct answer. Front parallelogram area is height we need. Base is 13. Left triangle area is. Oh. Right parallelogram is. Okay. So this is 50 plus 40, 90. Okay. Now I'm going to multiply this. 12 plus 13 is on each side. So overall is 90 plus 6. I need to see. That seems incorrect. Oh, that seems correct. Sorry. This seems correct. This seems correct. Ashrita, where did you go wrong, ma?
I don't understand how you did the right parallelogram one. I think I messed up there.
Right parallelogram, what is the measurement you took?
I think I took 12 times 18 instead of 12 times 9.51 times 18.
Sorry, Ashrita, slow down. What is that? 12 times?
I think I just took 12 times 18 instead of multiplying it
Oh,
by
if
0.951.
it is a parallelogram, how can you take both slant heights?
Yeah, I realized that. So I was looking at it, I thought it was going to be the height, but then I realized that it can't be the height.
Yeah, if it's a parallelogram, you have to understand that the perpendicular has to be taken between the bases. If you take this, right? Yeah, you can take this 12 as the base. But then the height that connects them is the perpendicular height. You got it?
Okay. Okay. And I have a question. Why did you write 0.951 times 25 at the bottom?
Oh, that is because meaning these two, I added them together, ma. I took this as
Okay.
common out. Or distributive property. I took this as common and then added these two
Okay.
for me to make it easier.
Okay.
Srishti, Mitransh, did you guys get it? This was one hard problem we're doing.
Now I understand.
Okay, Vinisha didn't get it. Vinisha, can I help you? Mitransh, can I help you?
Yeah, how'd you get the front parallelogram? Because
Okay, we'll discuss one by one, ma, because this is a little hard, as I said. So, front parallelogram, right? This one is this, this, right? I cannot use this as my base and this as my height. Okay, in a parallelogram, how do you find the area? It's not like L times B, it's B times H, the perpendicular height that.
oh, okay.
So, in a parallelogram, we know that this is 13, right? But what is connecting the bases? The perpendicular height is connecting the bases even if it is outside. You got it? So the front parallelogram would be 13 times that height. 13 times, what is that height? 18 times 0.951. You got it?
Yeah, I got it.
Okay, now Mitransh, where are we?
I understand when you explained it.
Oh, okay. Okay. Who else? Mahi, did you get it?
Yeah.
Okay, oblique you should be able to do because see, grade 7 we were able to do the rest already. So some addition should be there in geometry, right? So obliques you should be able to do, but understand if it's a parallelogram, don't get deceived. Don't take the slant height. Taking the slant height will make a mess for you. Sahana, are you with me, Sahana?
Yeah, I understood it.
Okay. How about Srishti Vibha?
Yeah, I can.
I understood.
Okay. For if ever you see a right triangle, one of the sides are missing, use sine theta cos theta. Sine 72 will be opposite by the hypotenuse. You can use that to find all of the sides. Can I move on from here? Yeah, this was a difficult one. I'm glad I saw that now. Now, let's see. We want to do more of this. You can do at home. Okay. Okay, how do you find, I want to see how do you find the polygon area? I didn't go over that with you guys. Let's see. Okay. Do you want to try one more of this, guys? Oblique. Let's see this one. It's interesting, but yeah, it is going to be difficult because it's just the same that we did, but you're going to be on your own. Let's see. I'm going to take 5 minutes more of your time, okay? Go ahead and try this one. But yeah. Again, you need to use trigonometry first. There is an angle given and a right triangle clearly given. After this, we'll go over one more concept and then you can leave. We will continue this discussion. See, what we are covering is a little bit in depth because I want to bring in trigonometry into this as well to find out the sides, because you will get problems like that. Without trigonometry, 3D surfaces doesn't work. Don't memorize formulas at all. Times perimeter. Apothem is, oh wow, you should know how to calculate apothem. Did you discuss polygon areas in school, Ashrita?
Yes.
Mm. Okay, I have questions for you. Let's see. We have discussed special right triangles already, right, guys? 30, 60, 90 and 45, 45, 90.
Yes, I think we did that over the summer.
Yeah, let's see. Yeah, meaning they can really give a lot of problems in this. Let's see.
Miss Priya, how do we figure out the height of the base? Because isn't that also a parallelogram?
Which one?
The height of the base. The height of the base.
Height of the base. I don't get you, ma'am. Meaning, feel free to draw on the board.
Because, like, isn't this the base? So, like, that's a parallelogram. How do we figure out the height?
That is not a parallelogram. Why do you think it's a parallelogram?
Because it's also slanted.
Did you see this?
Okay.
Make sense?
Yes.
The top is clearly a rectangle. Top rectangle. Bottom is as well a rectangle then, right? Right side is as well a rectangle. Bottom rectangle. Right rectangle, because it's clearly marked. Right? Only the problem is front and the back. If right is a rectangle, left is as well a rectangle. Makes sense. But the front and the back are parallelograms. That makes it hard. Top rectangle is 20 times 16. Let me put it properly. 20 times 16. Bottom rectangle is 20 times 16. Right rectangle is right rectangle is
Right rectangle is 16 times. I haven't figured out x yet.
right rectangle is 16 times, what is this?
X. But we have to solve for x.
Yeah, I think that, yeah, see, that is unknown. We need to solve for that. How to solve for that? Again, come back to your trigonometry. So I have to see something that connects my opposite side and my hypotenuse. That is sine 59 will be equal to 18 by x. So what is x? X will be equal to 18 divided by sine 59. Can one of you find out and tell me? But these are Little hard
What
problems.
place do we round to? Because the answer was 20.99940,115.
20.9. Ma, let me take it
20.99940,115.
as 21, ma. Okay.
Okay.
Right rectangle is 16 times 21. Left rectangle is 16 times 21. Front parallelogram is 20 times 18. Can one of you add and tell? That's it. It takes, yeah, meaning you'll have to do it slowly, guys, when it comes to 3D oblique solids. Oblique solids, they won't ask maybe, but you should know, guys. For SAT, ACT, if they ask, you have to be prepared, right? Maybe, see, school level geometry may not go, but sometimes some teachers definitely ask all these. Did you get it? Now 20 times 16, 16, 32 plus 36. Then, oh no, no, I'm doing, yeah, plus 16 times 42. 68 times 20 plus 16 times 42. You will have to do this and tell me the answer, guys. One of you, please do. 136. Yeah,
I got 2032.
203. I can check. Ma, please work all these out. If you have a problem, one, how much, ma? 2032 is correct. But did you all get a hang of how to do? You don't have to get the proper answers, but if you get the hang of it, we'll move on.
I got it.
Yeah, and if it is a regular if it is a regular pentagon, right? If it is a regular pentagon like the regular hexagon can always be split into equilateral triangles, okay? When you split them into equilateral triangles, what? This is 60, 60, 60. Remember, you will have to use the divided into 2, that becomes 90, 60, 30. Triangles, if they are given one side, you should be able to find the others. There in the homework, there is a problem that uses this. If you don't get it, come back, I'll help you. Okay, see, for any polygon, if you want to find the area, the formula, that this you need to memorize this, because half times perimeter times apothem is the area of any polygon. What is this apothem? Perimeter, you know, to find out in a polygon. Half times perimeter times apothem is from the center, you draw perpendicular to one of the sides. This length is the apothem. So to find out the area of any polygon, let's say I draw a pentagonal prism. You should find the area of the pentagon, right? So the top area will be half times perimeter times apothem. Apothem is the shortest perpendicular distance from the center to the side. Okay, that will be given usually. If you have to find out, then you need to use the 30, 60, 90 or 45, 45, 90 triangle to find out. You leave that, that's okay. If there are problems like that, we'll do it again in class. But for easy polygon areas, you should be able to use this area half times perimeter times apothem. Any questions for me? Okay, guys, I'll stop here. See you all. We'll have a break. Next time when you log in, please use Math Rangers as password. Okay, I'll change it later. Okay, guys, any questions for me?
No, Miss Priya.
Okay.
Hi.
Have a
Miss
nice.
Priya, I have a question.
Yes.
It's about like the SAT and SAT.
Tell me.
So, like, are you allowed to use your T184 calculator on the like?
Yes.
Because I didn't see like that many people like using it, and another thing is that I don't know um how to get access to use it the next time I have to take like the PSAT and stuff.
Ma, take your own, ma.
I don't know if they'll like let me. That's the thing. Like that's what I'm
Oh
asking.
yeah, they will let you.
They'll
T84. Yeah. Yeah.
Okay then. Thank you.
T84 is good.
Yeah, because I want to learn how to use it for like some of the hard questions on like the SAT and PSAT. So yeah.
Can't you take the physical calculator with you?
Yeah, you can. But they also provide calculators. They actually provide like
Don't use that, ma. You take yours, ma.
okay,
You
okay.
get used to operations in yours, take yours. Because
Okay.
there, if they give some other calculator, you won't even know what buttons to press in such pressure. Okay?
Okay.
Hmm.
Okay. Thank you, Miss
Bye-bye
Priya.
then.
Bye.
But let me know if you have a problem. You got it?
Okay.
Bye, ma.